Welcome to TOK Insight, where we dive deep into the big questions about knowledge and how we understand the world. In today's episode, we're exploring how technological advances and new measurement techniques reveal the limits of previously revered scientific and mathematical knowledge. Let's get started. Science is built on measurement. The tools we use to measure the world around us define the accuracy of the knowledge we create. But what happens when those tools improve? Well, history shows that the more precise our measurements become, the more we realize how limited our old knowledge was. Let's start with one of the biggest shifts in science: Newton's laws of motion. For centuries, Newton's laws were the foundation of physics, predicting the movement of objects, from apples falling to planets orbiting the sun. These laws were so revered that they were considered universal truths. But then, technological advances, better telescopes, more accurate clocks let scientists measure extreme conditions, like the speed of light or the pull of black holes. Suddenly, Newton's laws didn't work in these extreme cases. Enter Einstein's theory of relativity, which showed that Newton's laws were just a special case of a much larger picture. This was a major moment when new measurement techniques revealed the limits of revered knowledge. This isn't just a science thing, though. It happens in math too. Euclidean geometry, the geometry we learn in school with flat planes and straight lines, was considered absolute for thousands of years. But as technology allowed us to look further into space, measurements showed that space isn't flat at all. It's curved by massive objects like planets and stars. Non-Euclidean geometry, which deals with curved spaces, emerged, especially in relation to Einstein's theory of relativity. So, what was once a revered mathematical model turned out to be just one piece of a much more complex puzzle. Technology, in this case, showed us that even mathematical truths can have limits. Now, quantum mechanics takes this a step further. Early 20th century technology like particle accelerators and electron microscopes allowed us to study things at an atomic level. And guess what? Classical physics, including Newtonian mechanics, completely fell apart at this scale. Electrons didn't behave like tiny planets orbiting the sun. They were unpredictable, sometimes acting like particles, sometimes like waves. This led to the rise of quantum mechanics, a new branch of physics that introduced the ideas of probability and uncertainty. The tools we use to measure tiny particles revealed just how limited our classical understanding of the world was. And this process is ongoing. In biology, the invention of gene sequencing technologies has transformed our understanding of genetics. We used to think inheritance was all about dominant and recessive genes. But with the ability to sequence entire genomes, we now know about epigenetics, how environmental factors influence gene expression. Our previous knowledge of genetics was just the tip of the iceberg. And in cosmology, powerful telescopes and detectors have revealed dark matter and dark energy, things that make up most of the universe, but we can't even see them directly. It's mind-blowing, and it shows that even our most revered scientific knowledge about the universe's structure is incomplete. So, what's the takeaway here? The knowledge we revere today might be tomorrow's stepping stone. As technology advances and new measurement techniques develop, we uncover deeper layers of reality, and sometimes we realize that what we thought we knew was just scratching the surface. Science and math are constantly evolving fields, and what's fascinating is that this process of revision and discovery never stops. Thanks for watching TOK Insight. If you enjoyed this episode, don't forget to like, share, and subscribe for more explorations into the nature of knowledge. Until next time, keep questioning the world around you.